This is lesson 12 for year 13 physics, and this is about connecting pre-charged capacitors, and this is the last lesson for DC and capacitors topic. So pre-charged capacitors will all have a voltage across the plates since they have been charged, and these capacitors could be connected either in series or in parallel. Now let's look at connecting pre-charged capacitors in parallel. How do you know they're connected in parallel? You will notice that the positive plates are connected together. That's how you know. Okay. When the capacitors are connected, what actually happens is that the charges will redistribute themselves until there is a common potential or a common voltage. So since C is equal to Q over V and V equals Q over C, your common voltage is total charge divided by total capacitance. So if there's two capacitors, C1 and C2, this is how you get your common voltage. Now when pre-charged capacitors are connected together, what we need to remember is that no charge is lost, however some energy is lost due to resistance in the wires. So here's an example. So the first thing is, how do you find the new charge on each capacitor? So I've just given us some values here for C1, V1, C2, V2. So initially you find value for Q using C times V. So here's your Q1. Similarly, here's your Q2. And how do you get your common voltage? Using this formula, you substitute and you get this. Okay, now how do you find what's the new charge on each of the plates? So charge is again C times V, so your capacitance doesn't change, but the voltage across each capacitor has changed. So you use the same capacitance, but the new voltage to get the new charge. Now how do you calculate the energy that's lost in this process? So we know that the energy that's stored in a capacitor is half QV. So you first find out the total energy before connecting the pre-charged capacitors together. So you get the energy of C1, get the energy of C2, add them together and you get this. And then you get the total energy after charge distribution. So you know the C, and this is the VCOM. So this is your C2 and the common potential, and you end up with some answer here. Yeah, I've got this here, 1.206, and then the energy lost is the difference between the two lots of energies.